Welcome to the Barefoot Rover testbed. We're using this location to collect thousands of runs, which will be used to train the next generation of smart rover wheels.
Imagine that you as a human are walking through the desert. Your shoes and socks are off. You're walking through soft, hot sand. There are rocks on the surface. You know if they're sharp, you know if they're round. You can even feel the rocks under the surface. Then finally, as you continue walking, you get to a place where the soil changes completely. It sticks together and it's cool, and you say there's water here. Everything I just described is what the Barefoot Rover project will bring to Mars rovers.
Imagine you have a rover on Mars, and you want to assess your slip risk before doing a next activity. Currently, this is done with visual images where you would look at the ground beneath you and determine that risk. But imagine you're on just a small amount of sand, but you have firm bedrock right below you. The Barefoot Rover technology would allow you to sense and feel that without having to see it in visual imagery.
The goal of Barefoot Rover is to use the pressure sensor data and the EIS sensor data to train the machine learning models to recognize the terrain that the wheel is driving over and any interactions of the wheel and the terrain.
This is the crossbow test cart. The crossbow test cart allows us to have repeatable and controlled data-taking systems. It has a string potentiometer that we use to calibrate the slip during the run. It has a Z-stage optical encoder that we use to verify sinkage, in addition to a force torque sensor mounted on the wheel itself, and two IMUs, one inside the wheel and one inside the cart itself. The wheel drives the cart, and the cart kind of just comes along and facilitates all of our data-taking processes.
To create machine learning models that meet the rigor of science and engineering applications, we need a lot of data and a lot of experiments. To do that, we've created over 1,000 runs over different types of materials, from very coarse materials to fine sands. We also created different amounts of slip and introduced hydration into different sands. But we can't just input raw data into a machine learning model. We create what we call features that describe what's going on underneath the wheel at one given point in time as a one number. For example, the difference between the pressure underneath a grouser and non-grouser can tell us something about the terrain. We create over 300 such features that collectively help the machine learning model to learn about the terrain that the wheel is driving over. This combination of hardware and software allows us to estimate the percentage of slip better than current visual odometry systems, detect the buried and non-buried rocks, and estimate the percentage of hydration in the soil in near real time.
The hardware and software technology contained within the Barefoot project is a component of future autonomous systems for vehicles all around our solar system, both here on Earth and afar, allowing them to interact with the ground like they've never been able to before.